So we learned a couple new formulas, sum and difference formulas, which then we could just add to all the other identities and formulas that we've got already, the Pythagorean and that kind of thing. And so what do we do with those? We evaluate functions, we verify identities, and we solve equations. So first we introduce these things, and then pretty much that's what we do with them, which are all the things that we've done up till now in the chapter with everything but this stuff. So these are the sum and difference formulas. Right? By sum and difference, it means you're finding the trig function of a sum of angles or a difference of angles. So inside the, sine, these u and v are angles, sine of u plus v. Right? It's not sine u plus sine v. Okay, then if you, after seeing these formulas, if you just say sine u plus sine v, then obviously we didn't learn anything, because that's how you might like it to work, but it doesn't. So if you just focus on the sine formulas here, they're very similar to each other, right? The sine of a sum and the sine of a difference. I mean, look at the formulas on the right. There's only one thing different between them, and that is, if it's the sine of a sum, that's a plus. If it's the sine of a difference, that's a minus. Everything else is the same. If you look at the pattern here, the sine u cosine v, cosine u sine v. So they keep their angles in the same order, u and v, u and v. And then this one, it's sine, then cosine, and then cosine and sine. And sometimes students will not write it exactly the same way. I mean, you don't have to write it exactly. I mean, you could switch this around, make that a sine v, cosine u. I mean, it's still the same thing. But I'm always kind of looking for it like this, because that's the way I learned it when I learned it. Right? Now, if you look at the cosine formulas, again, the cosine formula there's only one difference between the formula for a sum and the formula for a difference. And it is also the operator in between those two terms, but it's reversed. The cosine of a sum has a minus in between. The cosine of a difference has a plus in between. But now look at the cosine formulas. Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. They have proofs of these things in the back of the book to show you how they come up with these things. Josh, you awake there? And let's see. And then you got a tangent. Now, if you've already done the sine and the cosine, you could find the tangent just by dividing the sine by the cosine. Right? The tangent of u plus v is the sine of u plus v divided by the cosine of u plus v. Right? Or you use these formulas. And again, there's only two differences now between these two formulas. Right? And that is the sine. There's two terms in the numerator and two terms in the denominator. And for the tangent of a sum, then that's a plus, and that's a plus, and that's a minus. For the tangent of a difference, that's a minus, and that's a minus, and that's a plus. The terms are the same. Tangent u, tangent v. 1 minus tangent u, tangent v. Right? Everything else is in the same place. So those are the sum and difference formulas. So now we'll do a few things with them. Right. So this one, I actually put up their example first, and then we'll do one which is just about the same. Because if, for example, you're given this problem of find the exact value, again, what does it mean to say exact? Yeah, we're looking for answers that include unresolved square roots or pies or whatever it is, right? Not to just put everything in the calculator, because you could clearly put that in the calculator, but you wouldn't get an exact answer. Now, is pi over 12 a unit circle angle? No, because we just have the fourths and the pi over 6, pi over 4, pi over 3, and then all the multiples of those things going around. But pi over 12 equals pi over 3 minus pi over 4. Now that part you may not be, might not come readily to you, but once you've seen it, maybe it'll come to you a little quicker than that. But again, if you find common denominator here, that would be 4 pi minus 3 pi over 12, which is pi over 12. Now both of those are unit circle angles. So we can use the sign of a difference, because it's a minus, sign of pi over 3 minus pi over 4, and then use the formula. Right? Since it's a difference, that's a minus. It's sine u cosine v minus cosine u sine v, right? Where the u is pi over 3, so it's here and here. The v is pi over 4, so it's here and here. Now all of those, if you know the unit circle, you can evaluate, right? That'll be the sine of pi over 3 is square root of 3 over 2. The cosine of pi over 4 is root 2 over 2. Right? The cosine of pi over 3 is 1/2. The sine of pi over 4 is root 2 over 2. Simplify. Root 6 minus root 2 divided by 2 times 2, 4. So, but you would have to remember, somehow you always got to turn these into angles for which you know the coordinates, because they're unit circle angles. And sometimes they're using radians, and sometimes you're using degrees. So that was the sine of pi over 12. Now, how would we do the cosine of pi over 12? Again, you got to turn that pi over 12 into unit circle angles, and we just did it. Right, that's the cosine of pi over 3 minus pi over 4. But you turn it into a difference, and then you use the formula. Right? And the formula would be, remember, for the cosine, if it's a minus here, then it's a plus between the two terms. And it's cosine, cosine, sine, sine. So this is cosine pi over 3, cosine pi over 4, plus sine pi over 3, sine pi over 4. And then those are all unit circle angles. The cosine of pi over 3 is, these are all the same values we mixed around on the last slide. Right? That is 1/2. The cosine of pi over 4 is root 2 over 2. The sine of pi over 3 is root 3 over 2. The sine of pi over 4 is root 2 over 2. And now everything has the same denominator of 4. And simplify. 1 times the square root of 2 plus the square root of 6. Right? Root 3 times root 2 is root 6. Good. Viva? Angelina? Okay, so again, we could do the same thing with degrees. Right? The cosine of 75 degrees. 75 degrees is not one of our unit circle angles, but 75 is equal to 30 plus 45. And both of those are, so we should be able to do this using that breakup. Right? This is the cosine of 30 degrees plus 45 degrees. Okay, remember the cosine formula, if it's a plus here, if it's the cosine of a sum, then there's a minus between the two terms. Cosine, cosine, sine, sine. Cosine of 30, cosine of 45, minus sine of 30, sine of 45. And those are all unit circle angles that we should know the coordinates for that. The cosine of 30 is root 3 over 2. The cosine of 45 is root 2 over 2. Minus the sine of 30 is 1/2. And the sine of 45 is root 3 over 2. So these answers, they always look alike. You know, there's just so many different ways you can put together some unit circle angles to come up with some indifference. So this is going to be root 6 minus root 3. That's wrong. That it was supposed to be root 2 over 4, which looks like maybe 2 answers ago. Let's see. That one was root 2 plus root 6. This one was root 6 minus root 2. Oh, and that's exactly what we got. Okay. Good. Morgan? All right. These are kind of typical problems you get with these sum and differences, which is find the exact value of cosine u plus v given that the sine of u is 12 over 13 and u, the angle, is in between 0 and pi over 2. Okay, which quadrant are you in if the angle is between 0 and pi over 2? But that's first quadrant. That's what they're trying to tell you. Draw your triangle in the first quadrant. And for v, the cosine of v is negative 3/5. The v, the angle v, is between pi over 2 and pi. Which quadrant are you in? 2, right? So you need to draw triangles. 2, and we could draw them on the same background because we're using quadrant 1 for one and quadrant 2 for the other. So I'll do it like that. So for u, which is in the first quadrant, I draw my terminal side from the origin out. Right, this is u, and I label 2 sides. Since the sine is 12 over 13, that's going to be opposite over hypotenuse. And then for the v, right, it's the second quadrant, so I'm going to draw the terminal side into the middle of the second quadrant and label the v right there. Cosine is negative 3/5, so that would be negative 3 over positive 5. So now you need to fill in the missing sides in both triangles with Pythagorean theorem. Okay, what about this side here? I mean, that'll be the square root of 5 squared minus negative 3 squared, 4. And how about this side? The square root of 13 squared minus 12 squared, which is 5. Okay, now that you got the 2 triangles set up, we need to use, this is the cosine of a sum. So we need to write that out. The cosine of u plus v is cosine u, cosine v, minus sine u, sine v. And then all of those you could tell by looking at these triangles. Right? Cosine of u is, here's the u, the cosine is adjacent over hypotenuse, 5 over 13. Right, the cosine of v, which was actually given to us, is negative 3/5. Right, the sine of u, which was given to us, is 12/13. And the sine of v is over here, 4/5. Simplify, right? Negative 15 over 65 minus 48 over 65, which is negative 63. You're good. Eva? You're good. Okay, write the sine of the arctan of 1 plus the arc cosine of x as an algebraic expression. Okay, so what formula do we need for this? We're doing sum and difference formula, so which one is it? It's the sine of a sum, right? It's the sine of a sum. So we need this one. Sine of u plus v equals sine u cosine v. That was bad. Sine u cosine v plus cosine u sine v. But this time our angles are actually inverse functions. So this is going to look like this, right? The sine of the arctan of 1 times the cosine of the arc, get this right, arc cosine, the cosine of the arc cosine of x, plus the cosine of the arctan of 1 and the sine of the arc cosine of x. So let's see, it's sine, cosine, cosine, sine. The first angle is here and here, and the second angle is here and here. Okay, let's see what we can simplify. The sine of the arctan of 1. Okay, it's saying, what is the sine if the tangent equals 1? Where is the tangent equal to 1? Remember, and you're only looking between negative pi over 2 and pi over 2. Where is the tangent equal to 1? Root at pi over 4, right? And what is the sine? Root 2 over 2. So this thing right here is root 2 over 2, right? It's what is sine when tan equals 1? Okay, what is the cosine when the cosine equals x? X. They should cancel each other out, right? We're taking the composition of a function and its own inverse. So that is x. And how about this one? The cosine of the arctan of 1. Again, it's this kind of thinking. What is the cosine when the tangent equals 1? Root 2 over 2. And then the sine of the arc cosine of x. All right, that one we'll have to do just a little bit of work for. Right, if the cosine is x, right, and here's our angle right there, then the cosine is x, adjacent over hypotenuse is x over 1. Cosine equals x. And now in order to know what the sine of that is, then we need to find that side. Square root of 1 minus x squared. Okay. Now, what is the sine? Opposite over hypotenuse. And you could factor out a square root of 2. You really can't do much with it in the end. There's no way to like put these terms together. I guess that the most you could do is this. Okay, use a difference formula to prove the cofunction identity. So remember, we have identities that look something like this. Is that actually one of the identities? Exactly. I'm going to open that up. That was in the first section, right? That was 5.1. You have it right in front of you, blank sides. Cofunction identities. So if I'm looking at this right here, notice all of these, there's no minuses in front of any of that. It's not exactly one of these cofunction identities. Right? Sine x minus pi over 2 equals negative cosine x. Okay, what else is different between this and this? Yeah, I mean, and on the one we're doing, it's x minus pi over 2. These are all pi minus 2 minus x. Okay, let me see if I go back to, and it's a sine. So normally we would expect for this one right here that it's pi minus 2 minus the angle. Okay, if I do this, right, if I switch the order, if I make it u minus pi over 2, then that's actually needs a minus in front. If you flip the order like that, then it makes it negative, right? 3 minus 1, 1 minus 3, they're opposites. So by switching that, it's like we're taking the sign of a negative angle. Okay, then you go to these, right, the even and odd. The sign of a negative angle is negative the sign of the positive angle. That's where the minus is coming from. So on this one right here, it would be, that should equal negative sine of u minus pi over 2. And then we would know that that should equal the cosine. Or actually, I think they got sine of u minus pi over 2 equals negative cosine. So they just moved that to the other side. So by switching these, it made a negative there. It's not exactly one of our cofunction identities. Okay, so now we're gonna try to use the difference formula to show that the sine of x minus pi over 2 does equal negative cosine x. So you got to use the difference formula for sine, right? Which would be sine of the first angle, cosine of the second, and it's a difference, and with the sign that would make it a minus, cosine of the first angle, sine of the second. And let's see, when you get to this step, you can always evaluate. I mean, the two functions there that you actually have an angle filled in, you could tell what is the cosine of pi over 2. Cosine of pi over 2. Right? What is the x coordinate right there? It's 0. So this is 0. That whole term drops out. It's 0. And what is the sine of pi over 2? It's 1. Okay. So what's left? This whole term dropped out, and we left with negative cosine x. And that was what we were trying to verify. Now you could have skipped, if you were given this, verify this identity, you could have skipped that whole part of, showing, oh, they switched the order of that. And I mean, if you're just given this and told verify it, then use the difference formula. I think this is the last one. Okay, find all the solutions for, and we've got the sign of a sum plus the sign of a difference. And it all equals 1. I think these are the ones that generally, when you get them on the test, there's a lot of just writing down on the next line. It says sine x plus sine pi over 2. Like you just don't use the formula. Let's just pretend like you could do it as your intuition would tell you, which is wrong. Right? But you need the formula at that point. Right? This is the sine of a sum. Right? Sine x cosine pi over 2 plus cosine x sine pi over 2. Okay? That's using the sign of a sum. There. Now, plus the sign of a difference. Sine x cosine 3 pi over 2 minus cosine x sine 3 pi over 2 equals 1. Right, so necessary first step. You got to, use the sum and difference formulas. Now you can simplify. So some of those you can evaluate. What's the cosine of pi over 2? We just did it. That's 0. So this whole term is 0. What is the sine of pi over 2? 1. What is the cosine of 3 pi over 2? It's 0. Remember, the 3 pi over 2 would be here. So the x-coordinate is still 0. And the sine of 3 pi over 2, right there, is negative 1, right? So negative 1. Right, when we put all that together, 2 of our terms dropped out. We're left with cosine of x, all right, minus negative cosine x equals 1. Right, there's the minus and negative, which means this is cosine x plus cosine x equals 1. 2 cosine x equals 1. At that point, it should look like one of our most simple of the equations that we solved before, right? Just divide by 2. Cosine x is a half. And this one definitely said we only want those answers in the interval 0 to 2 pi. Where is cosine equal to 1/2? Here and here, right? It's positive, and so cosine, the x-coordinate is positive to the right. But it's the, of the points on the unit circle that have 1/2 and the square root of 3 over 2 in some order, right? If the 1/2 is the least of it. So if you're up here, the x-coordinate is much less than the y. That's the one you go for. So x equals pi over 3, and then straight down 5 pi over 3. Is it good? So let's see. Did we do it all? We used sum and difference formulas to evaluate trig functions. I have to say, we didn't have any that were tangent, but you just it's in front of you, so you should be able to just use it. We verified the one identity, and then we solved the equation. That's it.